Today we will be going over an introduction to chemistry. Chemistry, it does matter. Matter is anything that has mass and takes up space. So you could probably come up with lots of different examples of that. Anything that's in this room, like desks, chairs, your pencil, you. But there's other things that take up space as well that you might not think of, like air. Air is matter. It does have particles, and we'll get into states of matter and things like that as we move forward in other days. This is what we'll be covering today. Matter can be classified as pure substances or mixtures, and you can see here physical methods preparing mixtures. We actually physically mix them together, where pure substances are things like elements and compounds and cannot be broken down into something simpler. Mixtures, we have heterogeneous or homogeneous that we'll be covering today. Pure substances are things that cannot be broken down into simpler substances chemically, and that's the key part there, chemically. So we have elements and compounds, as you can see here. We'll focus on elements first. Elements are pure substances that are made up of atoms. And atoms, it's a key word you need to know. They're smallest part of an element that has all the properties of that element. So show you what that looks like. An atom has distinct parts: a nucleus, which will contain protons and neutrons, and protons are positive, and then energy levels that contain electrons, and electrons are negative. Atoms, like if we have oxygen, the smallest part of a room full of oxygen or a container of oxygen is an atom. And the atom itself has all those properties that still make it an oxygen atom. Elements can be found on the periodic table, and we'll be covering some of these as we move on to further chapters. You can see they're classified by metals, nonmetals, and kind of what they do and what their properties are. Compounds are pure substances as well, and they are made up of molecules. And molecules are similar to atoms in that atoms are the smallest part of an element. Molecules are the smallest part of a compound. And this is where two or more atoms are chemically combined. An example is our water molecule. We have two hydrogens that are combined to one oxygen. And this chemical formula would be H2O. Chemical formulas, we will practice learning how to make them and learning what to do with them in Chapter 5. But you can see here they are symbols, the symbol that represents the element, and numbers. The numbers represent how many of that particular element we have. Now moving on to mixtures. Mixtures are materials that can be separated by physical means into two or more substances. So in a mixture, it's something that you physically put together. Generally, that's a good way to think of it. You physically put together Kool-Aid mixture into water, and so you stir that and you physically put it together. These things are generally easy to identify, but they can be tough to identify the two types, homogeneous and heterogeneous. So homogeneous are also called solutions, or also known as solutions, and it is a mixture that is uniform in its properties. Like you can't actually tell that it's mixed together. In this glass, you can tell that there's something red in there, so you might assume it's Kool-Aid, but if it was a clear, like if you can buy those clear Kool-Aid packets and put it in there, you might not know that it actually wasn't water. So salt in your water or sugar in your water, you might not be able to see that it's there. You can produce a solution that is too concentrated, which would mean that you have put too much of the solute in, and the solute then will fall to the bottom. Heterogeneous mixtures are mixtures that have physically distinct parts. And so there's some examples we'll go over here in just a minute, but there's two main types. A suspension is when the particles separate out. An example would be orange juice, where you actually have to shake it before you use it. A lot of medicines are suspensions. Colloids are particles. Colloids happen when particles can separate light. An example is fog. If you were to be driving in the fog and you turned your bright lights on, it actually separates the light and scatters it, and so it's actually harder to see if you use your bright lights. And that's why in cars sometimes they have fog lights that go underneath the fog. They point down at the road and kind of underneath the fog. So a couple picture examples here, a suspension, the particles are separated out, this oil and water. And then a colloid, you can see there's two things here. The one on the right is the colloid where you can tell that it's mixed in, and if you were to shine a flashlight through that, it would scatter the light. The light would not go directly through it. Here's some examples of heterogeneous mixtures as well. Water and sand, the sand will drop to the bottom and so it separates out. And then an example here with taco. So it's broken down into its separate ingredients. You can see it's all mixed together. It's just a group of randomly mixed items. Now, mixtures can be separated by physical means, and so some examples of physical means would be things like evaporation, filtration, condensation, chromatography, and distillation. So I'll go over those kind of quickly here. Filtration would be using some type of filter paper. You would pour the substance into another container and allow it to travel through filter paper. So you might gather sand and then the water would still travel to the next beaker or flask or container. Evaporation, you would maybe have salt water combined together and you would heat the water. Water and salt have a different boiling points or different heating points, and so the salt would remain in the container and the water would evaporate out into a gaseous state. Condensation, you could then put something up above the evaporated container, the container that you're heating, and the water would evaporate. It would hit that cooler container or cooler substance, cooler surface, and it would condense, and then you could collect it into another beaker. So you could have pure water in the beaker and you could have salt in the heated beaker. Chromatography separates out different color dyes, and this picture here kind of shows what that would look like. If you were to take a pen of different colors, red, blue, yellow, and green, as you can see there, basically what would happen, you put a dot on there, you put it into a solvent, generally that would be water or maybe rubbing alcohol, something like that, and then the dye colors will separate out when you set just the bottom piece of that paper into the solution or solvent. And you'll see how ink is made up of different colors. It's not just red or it's not just blue. It might be, if green, you might notice the red and the blue that has made that up. And then distillation is when you can get a solvent from a solution. So same idea as evaporation and condensation. You are just combining those two processes so that you can get the two different substances or three different substances separated. Okay, so a review of matter. Matter, again, can be separated into pure substances and element. You can see the picture there. Those are pictures of atoms or representations of atoms. So an element is containing only atoms of that particular element. A compound is two or more atoms chemically combined. A mixture, we can have homogeneous mixtures, which you can see there, the two separate types of particles. So we have atoms that are in the orange and we have compounds that are in the green, and they are mixed evenly throughout the entire mixture. And then heterogeneous mixtures generally separate out. So you can see there it's two separate types of compounds and they have separated out. They are not evenly mixed together. To review over mixtures quickly again, a solution or homogeneous mixture is when table salt dissolves in water and it forms salt or saline water. So we have the solute, which is salt, and it's dissolved in another substance, water, which is known as the solvent, and this creates a solution. A suspension, an example here, flour suspended in water. It appears light blue because the blue light is scattered off of the flour, and the particles are larger, and so you can see that mixture there. A colloid, and eventually, on the suspension, eventually that flour will separate out and drop to the bottom, and it'll kind of give you this milky looking substance. A colloid, milk is an example of a colloid. You can kind of read through there to see why, but colloids again can scatter light as one of the examples of what they do. So this is our introduction to chemistry, pure substances and mixtures. You need to know the difference between them. You need to know the types, the two types of substances and the two types of mixtures. You can see here that it's put into a little diagram for you. Matter is separated into pure substances, elements, compounds, separated then into mixtures, homogeneous, heterogeneous, and mixtures can be separated out by physical means.